Just waiting for it to officially start. Give me the message that it's right. So we're on. All right. So today we want to focus on decision logic. And as I said before, the reason that I'm kind of pushing forward with this decision logic is that is because of the fact that we will be using sequence as a thing once we're moving forward. So, sequence is inherent to all programming. Decision logic, you could write a program that don't have decisions. You could write a program that don't have loops, but all programs must utilize sequence. So I'm not going to push on sequence as something to have to do. All right. So we start off with decision logic. And we know that decision logic utilizes making choices. How do we make choices in our head? All right. How do we make choices in our head? What do you do in your head when you have to make a choice? If I say to you, let me call somebody, Ola. If I say to you, this weekend, would you prefer to go to the beach or go to the mall? Ola, tell me in your head how you make that choice, how you come up with an answer.
So I would weigh both options and then see which one is one that I would enjoy the most.
Right. So I like that answer. That's a real smart answer. You weigh both options. So if in your head, you're going to think to yourself, okay, I'm going to create a variable called beach, and I'm going to create a variable called mall. And I'm going to come up with some sort of way to give these two scores. And the one with the highest score is what I will want to do. So in your head, and Ola, I just running with your solution here, you might be able to say, okay, can I take my friends? Or what are my friends doing with respect to going to the beach or going to the mall? And maybe, in terms of the score you give for friends going to the beach as opposed to going to the mall, the friends that you go to the beach with, you might rate them as 15 out of 20. And the friends that you go to the mall with, you might rate as 14 out of 20. And then you will look at cost, okay? And you say, okay, well, how much money I have or how much money my parents willing to give me. And, what could I get on the beach for that money as opposed to what I could get in the mall for that money? And I might rate this at 17 out of 20 for what I could get on the beach as opposed to 13 out of 20 in terms of what I could get in the mall, because you might go and you might see something and you don't have enough money to buy it. And so you while you have fun in the mall with your friends, you don't get the full experience because you can't spend money like you want in the mall, right? And the amount of time that you could spend on the beach as opposed to the amount of time you could spend in the mall. And you might say, okay, I know my friends, we just end up going up to the beach late, and who does want to leave early because they have something to do? So, that might be a 9 out of 20, whereas the mall, we could spend more time in the mall. So this might be a 14 out of 20. And, any other criteria that you have. And you weigh it up. Okay? So 15 and 17 is what? 32. And 32 and 9 is what? 41. So you end up with 41 out of 60 as your score for the beach. As opposed to the mall, which is 14 and 14, which is 28, and 10, which is 38. And look at that, 38 and 3 is 41 out of 60 for the mall. So now you end up with a tie, you might have to make some other criteria. What's another criteria that we could make for beach or mall? Anybody?
Food.
Food, right? So the range of food you could get on the beach kind of limited to pies or bacon shack, as opposed to the mall where you could probably get pizza, everything from pizza to chicken to you know, you have a wider variety. So in terms of the beach, the food might score a 15 out of 20, whereas in the mall, the food might score a 19 out of 20. So at the end of the day, right, you end up with a 56 out of 60 for going to the beach, whereas you end up with a 41 and 90, sorry, 56 out of 80, right? Whereas you end up with a 60 out of 80 for the mall. And now in your head, it's the decision is clear. Yeah? Because you now say, okay, according to my criteria, the mall has more points, so I can go to the mall. This makes sense? Is this kind of like what everybody does in their head when they have to make a decision? No? Clement, what do you do? I see you shaking your head. Nah, I don't give it scores.
Say well,
Clement, you follow your heart?
something so say.
All right, go ahead, you can talk.
Yeah, say well, you know, if it's like the beach or the mall, say, where I feel like to go today. And like maybe give it like one criteria, maybe like how long I visit each or something like that. And then be like, you know what, I'll just go with flip a coin or something. If I can.
Well, you see? So everybody have different criteria. Elan, you're gonna share?
So no, I just now think our next criteria you could have used when last I went to the mall or when last I went to the beach.
All right. So that's a big criteria, right? I'm just gonna name it when last. So when last you went, and how you gonna score that? Maybe you ain't go to the beach in months because of this state of emergency and ban with COVID. And, you know, is it over a year yet or something? So must be at least half a year or 9 months or something. So I don't know. But we can then say, okay, when last we went to the beach, and that could be like 100 out of 100. Whereas when last you went to the mall, the malls got opened, and even though they're not as special as they used to be, you pass through the mall, you pick up a little, you pick up a little treat, you pick up a little food, you went and you buy a jersey or something. So now this is 50 out of 80, sorry, 50 out of 100. So now that you know, and maybe this could boil down to human mood as something, because the thing is, the mall could be objectively better, but you still, as a human, have this thing that we can't explain called a mood, and you're just in the mood to be on the beach. So at the end of the day, human decisions are illogical, even when we try to put logic to it. So your mood and when last you went to the beach totally overshadow your decision, as opposed to the going to the mall, even though the mall could offer you a better experience at this time. Because I could tell you all, as soon as I could go to the beach, right? If I lay hearing coconut trees and breeze rustling in the back of me, right, well, I have to teach you. Just don't say nothing. Okay, I will be there. Right, and just because this is recorded, that is a joke. I am not going to teach any classes on the beach if anybody is reviewing this in the future. Okay, but it might happen, right? But you know, so decision making boils down to this. Decision making boils down to this. Okay, for human beings, it goes to And Omar bring up a good point there just now too, that a big variable is weather as well. Okay, but right now I might be so thirsty for the beach that it could be thunderstorming, and I might be in the beach and loving it, right? Just be like it cold and it's rain and you know, right? The waves mean and all of that, and I just trying to make the best of it because I'm so thirsty for the beach. All right. I look at tell the teacher missing the beach. All right. But you know, this is like the basis of decision making. And then once we get our score, this boils down to a simple statement. It boils down to a statement that says if the variable beach has more points than the variable mall, I go to the beach. Otherwise, I go to the mall. Okay, that's what it boils down to. It basically says here, if, and I want to underline if, beach has more points then go to the beach. Else, go to the mall. And this is what it breaks down to in terms of a decision for us. In terms of what we want to do, we essentially, in our heads, put weights to two variables, and the one with more weight is the one that we follow. And this is the basis for all of decision logic, or most, let me say most, because we have another structure, but I will introduce that structure a little later on. All right, this is the basis for almost all of the decision making that we will be doing in programming. The if statement. So your if statement allows us to make a decision based on the fact that we say if some criteria is true, if some criteria is true, right? And as I've said before, the then is implied, but I don't usually include it. Then do an instruction. Then we do an instruction. And this is all there is to making a decision. And this is what guides us as human beings, everything that we do. Okay? If you're feeling for a snack, then find something to munch on. If you're feeling hungry, then find some food. If you're feeling sleepy, then take a rest. But I know that you all are adolescents, so the statement there might be, if you're feeling sleepy but not exhausted, then continue watching the show on Netflix because it's going really good, right? And only when I am on the verge of collapsing and I know that there is 3 hours before I have to wake up for school, and, you know, I really should get to that homework that I was supposed to do, maybe I should take a 2-hour snap, all right? And squeeze that homework in for 1 hour before class. So stop me if I'm lying, eh? All right? Stop me if I'm lying.
How you know us so well?
I know I was there, right? And you know, it catches up with you. It does. All right. So this is the if statement, and from this simple if statement, we can take a look at some other structures, because this if statement alone implies if a criteria is true, then do an instruction, otherwise do nothing. But what if we want to do one of two things? Then we have to introduce us a structure that says if else. If else. So now we have if criteria is equal to true, do an instruction, right? My INS is short for instruction. Else, do instruction 2. So we have two different things that we can do, and I've forgotten to put something up here, which I want to put because I want to make sure that we get in the habit of doing it. At the end of each if statement, you put an end if. And we do the same thing for down here. If criteria is equal to true, do an instruction, else do an instruction 2. And if. So what does this one tell us? All right? What does this one tell us? This one tells us that we can make a binary decision. Whereas the previous one tells us that it's either you do one thing or you do nothing. Okay? And of course, these are based upon scenarios. These are based upon scenarios. So we have the condition, if criteria is equal to true, you do the first thing, else do instruction 2. So we could go back to Omar's statement with the whether, right? And we can now apply that to this here, because we could have said, okay, before our statement was essentially if, right, if beach, let's just leave this by itself. If beach is, or let's make our decision. If weather is equal to good, go to the beach. End if. So we made our decision to go to the beach. And on the day of the beach, we have one thing to check. We just have to check and see if the weather is good. And if the weather is good, then we go to the beach. Otherwise, we stay home and sulk. That's what it, or, you know, we do nothing otherwise related to this activity. Whereas this second choice here now gives us the opportunity to say, if weather is equal to good, go to the beach. Else, go to the mall. And if this second scenario here gives us a choice, a better, you know, some kind of binary choice. Whereas the first one was ambiguous, as in, if we don't go to the beach, where do we go? What do we do? It's not clear to us in terms of instructions. You all with me? But this one now, by way of instruction, it says, okay, the mall is still up for grabs. The mall is still up for grabs. If the weather is good though, we go into the beach. Otherwise, we go into the mall. And then we have a last scenario, but you know, that might give us more opportunity. Will give us more opportunity. I could use straight lines in it. I know, and that looks so much neater. All right. Yes. It gives us more opportunity. What if we wanted to have more scenarios than just going to the beach or going to the mall? All right. So we have the if, else if, dot, dot, dot. And the dot, dot, dots indicate that these things can repeat else structure. So this structure, this last structure allows us to get multiple criteria. Okay? it allows us to do multiple criteria, and the whether is equal to good is kind of like a binary decision, right? It's either the weather good or the weather bad. Okay, so I don't feel I can extend on this example here, right? But we can, I'm going to run through this and then we'll take an example on something different. So we could say if, and again, we always try, if our criteria is equal, if criteria 1 is equal to true, right, then we do instruction 1. Else, if criteria 2 is equal to true, then we do instruction 2. Else, right, do instruction 3. So we have a scenario here, and we put our end if, where we have more than one criteria for making a decision. We have if our criteria 1 is true, we do the first instruction. If our criteria 2 is true, we do a second instruction. We could only ever do one of these things. Okay? It's kind of like you know, in the comics and stuff where they have like they have every decision you make kind of branches off to a new reality, possible reality. But you could only make one decision. That's the sucky thing about being in one reality is that you could only ever see the results of one decision. But you as the programmer now, you are kind of like that architect that makes that choice. You know, you kind of come like, I'm watching a lot of What If these days. So you come like, that watcher. So that you're able to see, okay, what would have happened if this happened or that happened, or where would reality have gone in that direction? I don't know if I'll watch What If. Give me a, am I totally off here, or you all seen the What If series? Yeah? Right. And actually, I find this pretty good. Right? I'm not that big a Marvel MCU fan, but like I've seen the popular ones, and I actually find the What If is pretty nice in terms of, I guess maybe because it's animated and it's close to comics, and I think I prefer reading and watching comics and animation than the movies. The movies always kind of, I know the movies just always kind of lack that absoluteness that the comics could achieve. But you shan't say that you've seen one episode. One episode is enough to get you hooked, Keyshawn. Right? I have one episode left, so I haven't seen the last episode yet. All right. So what we are as the programmer here is that we can see, or we can control what happens in all possible branches by using our if statements. The person using the program, however, can only, based upon what they've previously entered, follow one of these routes when this if structure is called. So if they have the criteria to fulfill criteria 2, then instruction 2 will get done. If they cannot fulfill criteria 1 or criteria 2, then in this case, because there's an else, and what the else means is that once everything else cannot be satisfied, then this is the catch-all. This is what takes place. This is what we do, right? This is, everything else could not be done. So this is what could be done. And, there can be more than one else if there. So you could have else if criteria 1 is equal to true, criteria 2 is equal to true, criteria 3 is equal to true, criteria. 4 is equal to true. And on top of that, you do not necessarily have to have an else at the bottom here. This else is optional. So you could choose whether or not you want to have that catch-all in the event that all the criteria couldn't be chosen, or if it is that all the criteria, if you want to do nothing, sorry, if none of the criteria hold true. All right, so this is that else here. Or if you want to do something, then we can do the instructions here, right, in that else. So that's the purpose of that else. So an example here would be like, let's say, for instance, example, accept, let me write this in a different color. So our example here, we're moving away from the weather example, is to accept 3 numbers and print the largest number. So how do we do that? If we have 3 numbers, we have to store them inside of 3 variables, right? So we can, if we have our algorithm, we can start and we can go int n1, n2, n3, right? Number 1, number 2, and number 3. We ask the user, we say print, enter 3 numbers. So we have 3 numbers being input, and we say n1, n2, n3. Now, I don't know which order or what values the users are going to put all these numbers in, right? So, and I'm putting down here, assume 3 different numbers. Assume 3 different numbers. Okay, because I know that somebody is going to say, but sir, what if the numbers are equal? Or sir, what if... we're assuming that it will always be 3 different numbers, because then later on in this class, I will get you to write the code that will tell us if 2 numbers are equal to each other and or not. Okay. All right. So n1, n2, n3, print 3 numbers, input n1, n2, n3. We are assuming that these are 3 different numbers. So how are we going to find the biggest number? How are we going to print the biggest number? The biggest number, we have to check multiple criteria to get this. We say if what? If n1 is bigger than n2 and n1 is bigger than n3. What do we do here? We could print out n1 is biggest. Okay? And then we have to check else if what? Else if n2 is bigger than n1 and n2 is bigger than n3. Print n2 is biggest. Now down here, what should I put down here? That this last criteria.
Else, print, and choose the biggest.
Right. We don't have to put any criteria here because according to what we know from this problem, we know that we under the assumption that all 3 numbers will always be different. And we know that we are under the assumption that, we know that we put in a logic to catch n1 being the biggest. We put in logic to catch n2 being the biggest. So else print, we don't have to put the logic that will catch N3. Because if this failed and if this failed, then it must be this one. Okay, so print N3 is biggest. And then we put our end if here, and that's it. Everybody with me so far? Anybody
Yes.
at this? Huh?
Yes, sir.
Yeah. So nobody at this point is like, well, I don't know what he talking about. I don't know how he's here. No, everybody's fine with where I am at. Yes, good.
Yes, sir.
Good, good, good. So I'm going to now give you a problem to attempt. I'm going to now give you a problem to attempt on your own. I'm going to give you a timer. I want to see if we can work out, using if statements, a solution for the following scenario. A hotel has a pricing policy as follows. Right? A hotel has a pricing policy as follows. 2 people cost $85. 3 people cost $90. 4 people cost $95. Any additional person is $6 a person. If the customer is staying on company business, they get a 20% discount. If the customer, or if let me say, if any customer is over 60 years of age, there's a 15% discount on the price. But a customer cannot get both discounts. Given the above data, print the cost of the room. So we want to write an if statement that is going to allow us to be able to attempt at getting a solution at this price. Okay, sorry, at this for this problem. Okay, don't make too many assumptions about it. Don't assume that you have to catch up to like 20 people or 15 people or whatever. Just do it for what's right in front of us. Okay? Anybody doesn't understand the task, I'm asking you to see if we can come up with an if statement, something like this. But there are additional things that we have to consider. Okay, but my advice to you is take it one step at a time. I think that I can give you, I feel like if this is a 15-minute assignment, what you all think about that? Yes? All right, so 15 minutes should be adequate in terms of doing this. Anybody want to chime in on that, or everybody agree 15 minutes seems pretty fine?
Yes, sir, that should be reasonable.
All right.
Show the if statement just one more time, just like 5 seconds.
This one here?
Yes.
The timer hasn't started yet, so can I move back to the question now?
Yeah, proceed.
Oh, okay, good. All right, so time has started. Okay, time has started, and I'm going to pause the recording, and when I don't just want 15 minutes of dead air, right? And when we're going through the solution, I'll resume the recording.